Welcome dears, we are here back with carboxylic acid and derivatives. The previous year questions, only 2 questions have been asked in January session from this chapter, so this will be only 5 minutes long session preferably. So let us go to the questions. Without much ado, let us move to the questions. Yes, we are here with the questions. So the first question is, find the major product. So we are having benzene and halo derivative of benzoic acid, and we are adding anhydrous AlCl3. You know that benzene is here, anhydrous AlCl3 is here, and water here. This compound is here. So acetylation happens. That is Friedel-Crafts acetylation happens. So very simple. What happens here? Acetylation means the Cl will go and the C will attach to this carbon, right? So we get C double bond O. Yes, this is our answer. So option A, B, C, S. Option D is the correct answer. Now we have question number 2. Sulfanilic acid. So which is sulfanilic acid? I think this is sulfanilic acid, SO3H NH2. Sulfanilic acid, we react it with these reagents NaNO2 NaNO2 and CH3COH. Here what happens? NaNO2 and CH3COH, you know that it is somewhat related with which thing? You have seen the same. What? Yes, not halonium ion. What I am telling is that yes, this reaction is somewhat related to the dye formation reaction. Dye, that is red dye, blue dye, yellow dye. And here look, NaNO2 and CH3COH. And here there is something related with diazonium salt. So here NH is gonna change. And we are gonna get in your NCERT, this reaction is not given, if I am not wrong. This is not given. This is a special reaction. But in amines chapter, how to rearrange diazonium salt is given, right? How to rearrange diazonium salt is given. So here what happens, we get N double bond N O C double bond O CH3. This thing we get. Okay, how do we get this thing? Nothing. Look, you know that if it was HX here, we would have got N2 like this, right? But now here we don't have HX, but we have which one? CH3 COO minus. Sorry. So here this thing will go and attach to this N. Therefore we got this. Understood? Yes. So we get N plus this minus. So that's it. Now this thing is X. Now when we react, that thing that is N double bond N O C double bond O CH3 with this thing, with this compound, you know that there will be a dye formation happening. How the dye will be formed? Look, you know that this thing is here. If this thing is here, dye formation is preferred. You have learned in your carboxylic acid chapter about coupling reaction. Here a coupling reaction will happen. What happened? This thing will go and join the para position of this NH2 group. So what happens? Hence we get let us change the orientation of this, then only we can draw it perfectly. Yes, this is SO3H is here. Here we have N double bond N. Yes, we have 2 benzene group, and here we have NH2. So this is the compound that we are gonna get. This will be a red dye. Okay, understood. Now let us check which is the correct answer. This one, no. Is it this one? No. Is it this one? No. Is it this one? Yes, this is the correct answer. This is the correct answer. Simple question, but humble question. Simple question, but humble question. Right? So by this, our video come to an end of January session. But I am thinking that we'll include April session 2 in one video, so it will be easy for us, right? So we'll be continuing the same video with the April session 2. Yes. So we have our April session question here. We are having 4 questions, so we'll be doing the same in this video itself. Okay. Yes. Here we have our questions from April session. So first question: the product C in the following sequence reaction has how many pi bonds? So first we are having benzene. Now we are adding KMNO4 and KOH. Oh yeah, this is the reaction from KMNO4 KOH heat, and we'll be adding the same H3O plus. So our reaction becomes simple. What we get? We get carboxylic acid. Is there in your NCERT textbook about exercise question 2? We get carboxylic acid. Now into this carboxylic acid, we are adding Br2 in presence of FeBr3. Anyway, however we add this Br2, the number of pi bonds will be the same or different. Anyway, if you are adding this Br into this compound, what happens? Br will come in ortho, para and meta position. You know that, right? So ortho, meta and para position it will come. But you know that here in your NCERT textbook, they however do not undergo Friedel-Crafts reaction. Here Friedel-Crafts reaction will not happen. Then what happens? Because carbonyl group is a deactivating and catalyst, aluminum chloride get bonded to carbonyl group. So here we get meta product. Here we get meta product only. No ortho or para. No ortho and para, but only meta product. So we'll get to what meta product. COH and meta Br. How many pi bonds are here? Just 1, 2, 3. So 3 pi bonds here, and in the COH the structure will be this thing. How many pi bonds? 2, 3, 4. So 4 pi bonds. That's the answer. Now identify product P in the following reaction. Bromine with red phosphorus. Which reaction is that? Bromine about HVZ reaction. Everyone please be careful. Is it HVZ reaction? Yes. This is Hell-Volhard-Zelensky reaction. HVZ reaction. So HVZ reaction requires a alpha hydrogen. Here is there alpha hydrogen present? Let us check. 1, 2, 3. Yes, here we have an alpha hydrogen. What happens? This alpha hydrogen will be removed and bromine will come and attach here. So we get the answer to be COOH Br. OH Br. So option 2 is the answer. It's CHO Br, right? Option 1 is the answer. Okay. Yes. So that is a simple question. Now third question. Major product of the following reaction has how many pi bonds? KMNO4 KOH, CH2 CH3. Add KMNO4 and KOH. Add KMNO4 KOH and heat. We get what? Simple. Yes. C double bond O minus K plus. Yes. Into this we are adding HNO3 and H2SO4 and H2SO4. So what we get? We get NO2 in the meta position. So C double bond O minus K plus and NO2. Okay, you can give the minus star plus star. I am just drawing the same for pi bonds. How many pi bonds are here? 1, 2, 1. Here totally there are 3 pi bonds inside this 3. Now 4 and 5. So 2 more, so that will be total 5 pi bonds if I am not wrong. 5 pi bonds, 5 pi bonds. So we have 5 pi bonds in the following. Sorry, this is not the compound. In B, 5 pi bonds. Now question number 4. We are having some compound. Oh, it's a very odd compound really. Yes. So this is the answer for the above question. There is no space for me to draw the same. So I will just explain this answer. Okay. So here look, we are having what, benzene group, and it is being attached to which one? Yes, this anhydride. This is an anhydride. You remember, this is an anhydride. And the toluene. You know that we can prepare, and AlCl3 is here. You know that this is like a Friedel-Crafts reaction itself. So what happens is that this O will be splitting from here. So we will be having a different this thing here, and the O will be going here. Now this will go and join anywhere in this ring, and we'll get 1, 2, 3, 4, 5. Double bond OH. This will be the compound formed. Now into this we are adding Zn and Hg and H2O, and this is called what reduction? Clemenson's reduction. So this thing will be changed to hydrocarbon. So we get this as our product. Yes, this as our product. Correct. Now into this we are adding concentrated H2SO4. H2SO4. What happens? This OH group, this H, here one H is here, right? This H2O will be escaping. Okay, will be escaping, and a cyclic bond will be formed. So we get as the answer. This is the answer for that question. Yes, here which one is the answer? Yes, this is our answer. 1 is our answer. So there are only these many questions in April shift, if I am not wrong. Yes, with that this come to an end, and April shift questions come to an end. Okay. Yes, the April shift was simple, but this some questions, especially this question was difficult. It was difficult. Okay, I accept it was difficult. This was okay. This was also okay. Only the first one was difficult. The last one was somewhat difficult. Okay. So I hope by this we complete the 3 organic chemistry chapters: haloalkene, haloarine, alcohol, aldehyde and ketone. Carboxylic acid is completed. Now we are having amines and biomolecules left in the part 2 textbook, and we will be doing it. But now we will be moving on to physics chapter, somewhat ray optics, wave optics and all of 2024, and we will be coming back. So thank you. Next video will be on physics or maths preferably. Okay, thank you for watching the video. Thank you.